Conic sections have geometric properties which play important role in the real world. One of the interesting property of parabolas is yung kanilang reflecting property. This property is used to design flashlights and satellite dishes. Some have been using this reflecting property to collect thermal energy from the sun. Much like parabolas, ellipses have applications too. In astronomy and classical physics, Johannes Kepler's first law of planetary motion states that planets have orbits that are elliptical in shape, with the sun as one of the focus. Also, most of the comets that go around the sun travel in a highly elliptical orbit. The reflecting property of ellipse plays an important role in the real world too. In medicine, they use this reflecting property in the treatment of kidney stones. So in this procedure that we call shockwave lithotripsy, the kidney of the patient is placed on one of the focus, while the high intensity wave is placed on the other focus. So andito yung isang focus and then andun yung kabilang focus. And then i-reflect nila yung mga shockwaves. So just like parabolas and ellipses, the reflection property of hyperbolas is also interesting. When light is aimed at one focus, this light will be reflected to the other focus. So let's have some applications of these problems. So you are designing a spotlight using a light source and a parabolic reflecting mirror. The casting has a diameter of 2 feet and the depth of 1 foot. What is the equation of the parabola used to shape the mirror, and at what point should you place the light source relative to the mirror's vertex? So for our solution, syempre i-visualize muna natin yung ating problem. And in such problems, maganda kung yung vertex natin or yung center natin, i-place natin siya sa 0, 0 para mas madali nating ma-solve yung problem. So in this case, let's say the vertex is at 0, 0. So since yung diameter natin is 2 feet, so meron tayong 1 dito and another 1 dito. Okay? And yung depth naman niya is 1 foot. Therefore, yung isang point dito is at negative 1, 1, and the other point here is at 1, 1. Note that these 2 points lie on the parabola. Ibig sabihin, whatever equation the parabola has, sinasatisfy ng dalawang points na to. So for our solution, since ganyan yung ating parabola, and the vertex is at 0, 0, so we will use x squared equals 4py. Now, we have to find what is p. So sabi ko nga kanina, since these two satisfies the equation, pwede tayo ngayong mamili ng isa, tapos i-substitute natin sa x and y para makuha natin yung p. So in this case, I use the point negative 1, 1. So our x is negative 1, then square it, equals 4p times 1. This implies that our p is equal to 1/4. So since alam na natin kung ano yung p natin, we can now substitute it in our equation to find the equation of the parabola. And the equation of the parabola now is x squared equals 4 times 1/4 times y, which is now x squared equals y. Now, for the second question, tinatanong, at what point should you place the light source relative to the mirror's vertex? So actually, the optimal point kung saan natin siya i-place is the focus. But we know that the focus has a p distance from the vertex. So meron kang p dito, and yung p is 1/4. So malamang andito yung ating focus. Okay, somewhere there. At dun yung optimal na placement ng ating light source. Therefore, the light source should be placed 1/4 foot away from the vertex. A satellite dish is in the shape of a parabolic surface. The signal, which are transmitted by satellites, strikes the surface of the dish and are reflected to the receiver. So, tumatama siya dito sa dish, tapos magre-reflect siya doon sa receiver. So, the receiver is placed on the focus. So, how far from the base of the dish should the receiver be placed if the satellite dish has a 6-meter diameter and 1 meter depth. So, ito lang yung this na sinasabi dyan. Hindi kasama yung patusok niya dyan. So, illustrating the problem, ganito yung kanyang itsura. So, since 6 meters yung diameter niya, 3 dyan, tapos 3 dito, tapos 1 meter yung depth. So, yung isang point natin is at negative 3,1, the other point is at 3,1. And syempre, yung vertex natin is at 0, 0. So, our equation is x squared equals 4py. Again, kunin natin yung value ng p by substituting any point of your choice. So, in this case, I use negative 3, 1. So, I have negative 3 squared equals 4p1, which now means that p is equal to 9 fourths. So, by substituting p to our equation, the equation now of the parabola is x squared equals 9y. So, tulad ng sabi ko kanina, the receiver must be placed on the focus kasi yun yung optimal na placement niya. Therefore, to answer the question na how far from the base should the receiver be placed, the receiver should be placed 9/4 meters away from the vertex. So, around 2 point something. Okay? Nandun yung ating receiver. The moon travels about Earth in an elliptical orbit with Earth at one focus. The major and minor axes of the orbit have lengths of 768,800 kilometers and 767,640 kilometers respectively. Find now the greatest and smallest distances respectively from the Earth's center to the Moon's center. So, yung Earth natin nasa focus, tapos itong Moon natin is at point kung saan nagtatravel siya. So, ang hinahanap natin dito is yung smallest distance from the Earth at syempre yung largest distance from the Earth. So, for our solution, we know that 2a is equal to 768,800. So, this means that a is 384,400. Kasi yung A natin, yun yung ating major axis. Okay? For the minor axis, 2B is equal to 767,800, which implies that B is equal to 383,820. Now, to get the C is equal to the square root of A squared minus B squared, or that is equal to 21,108. Our apogee, okay, is equal to, diba, this is equal to C, center to focus is C, center to vertex is A, so that is A plus C, or that is 405,508 kilometers. That is the greatest distance of Earth to the Moon. While the perigee, which is the shortest distance, eto naman yon. What is this ba? Diba, from center to Earth is C, center to this point is A, so A minus C, so that is 363,292 kilometers. That is our shortest distance of the Earth to the Moon. Example number 4, suppose that the orbit of a planet in a mini planetarium model is in the shape of an ellipse with a major axis whose length is 5 inches. If the distance between the foci is 4 inches, find the equation of the orbit. So, eto actually yung visualization ng ating problem. Sabi niya dyan, yung distance between the foci is 4 inches. Kaya, from the center to the foci is negative 2, tapos 2 dun sa kabila. Kasi yung center natin is at 0, 0. Tapos yung major axis natin is 5. So, ibig sabihin, from here to here, 5 dapat yan. Kaya yung vertex natin ay nasa negative 2.5 at nasa 2.5. So, gagamitin natin ngayon itong equation na to model our ellipse with A equal to 2.5 and C equal to 2 as given in the problem. Now, getting B, we know that B is equal to the square root of 2.5 squared minus 2 squared. So, that is 1.5. Therefore, our equation now is x squared over our A squared is 6.25 plus y squared over our B squared is 2.25 equals 1. And for the last example, a sculpture has a hyperbolic cross-section. So what is now the equation that models the curved sides of the sculpture? And if each unit in the coordinate plane represents 1 foot, what is the width of the sculpture at a height of 5 feet? So, eto yung illustration ng ating problem. For our solution in the first question, we know that the equation to be used is x squared over a squared minus y squared over b squared equals 1. Kasi yung center natin, nilagay natin sa 0, 0. Our a is equal to 1 based on this. Okay, na may measure naman natin siya. And then, since negative 2, 13, or kahit anong point dyan, okay, lies on the hyperbola, ibig sabihin, sinasatisfy niya yung hyperbola. So, pwede nating ilagay ito doon sa ating hyperbola, okay, sa x and y niya. So, we have negative 2 squared over 1 squared minus 13 squared over b squared equals 1. This implies now that 4 minus 169 over b squared equals 1. So, ito ilipat tayo sa kabila kasi ito dito. So, we have 169 over b squared equals 3. By cross multiplication, that is now 169 equals 3b squared, or b now is equal to the square root of 169 over 3. Therefore, we now have x squared over 1 minus y squared over 169 over 3 is equal to 1. That is now the equation of our hyperbola. So for our solution in question B, so alam na natin yung ating equation for the hyperbola is x squared minus y squared over 169 over 3 equals 1. So tinatanong niya dito, ano yung width ng sculpture at a height of 5 feet? Baka malito kayo baka akala ninyo 5 yung gagamitin. Pero yun diba, yung base ng ating hyperbola is ito kasi. Diba? Ito yung sculpture natin. So, at the height of 5 feet, so meron tayong height na 5 feet. Saan ba yung height na 5 feet na yon? Actually, that is at negative 8. Tama? Kasi negative 13 yung buong ito. So, negative 8 yung height na hinahanap. Diyan, yung point na yon. Yan yung ating 5 feet. So, since hindi natin alam ano yung x dito, pero alam natin yung y natin is negative 8, we can actually substitute negative 8 doon sa ating y and then look for the value of x. So that is now x squared negative 8 squared over 169 over 3 equals 1. So that implies that x squared 192 over 169 equals 1. Or that is now equal to x squared equals 1 plus 192 over 169, and x now is equal to 19 over. So, we know that x now is equal to 19 over. So, etong part na ito ngayon, that is now, okay, itong point na to, kasi ito yung sinasabi natin, this is now equal to 19 over 13 and negative 8. Etong 19 over 13, eto lang yun. Pero ang tinatanong, yung width ng buong sculpture. So, ibig sabihin nun, we have 2 times 2, itong x na to. Para isang x dyan at isang x dyan. Therefore, the width of the sculpture at the height of 5 feet is actually 38 over 13 feet or approximately 2.92